What is a system of equations? If we're going to be using it here, what is it? Hunter, go ahead.
Two equations that can be lines, or two equations that are lines.
They don't have to be lines, to be honest with you, but I agree with the, can I say one or more equation?
Yeah, one or more equations.
One or more equations, and for us,
That can be put into lines.
well, if they're lines, right? Now you're going to find when you get into like Algebra 2 and other classes that they don't have to be lines, they could be curvy things in a system. So I'm just going to say one or more equations. What else would you add to that?
One or more equations that are related to each other?
Okay, one or more equations related somehow. I agree. Makes sense. How many variables do we usually see with these?
Two.
For us, we've seen two different variables. It's possible to have 3 or 4 or 5 or 10 or 20 or 60. We're going to keep it at 2. Okay, so I'd say 2 different variables. And what are those variables typically?
X and Y.
Yep, 2 different variables, x and y, is what we most often see. And so we're going to be trying to work within that framework of looking for systems of equations using 2 variables, x and y. And we're going to try to use this problem-solving strategy. I'll read through this again with you. This is actually a carbon copy of what we looked at before. Ben has a question first, though.
Isn't it two or more equations?
I had 2 or more. Did I say 1 or more? I might have said it wrong. It should be 2 or more equations or more. I think I was thinking more than one and wrote 1 or more. Yeah, thank you. 2 or more equations that are related, 2 different variables, x and y. There we go. So that's what, does that make sense? Sorry for the typo there. Okay. So as far as the problem-solving strategy, I hate to break it to you, but whenever you come up against like an actual real-life type problem, you're going to have to read, right? And when I mean read, I want to be very careful about the way we talk about read. Have you ever done this? Have you ever been reading a book? Maybe it was just for fun. Maybe it was a school book or something. Have you ever been reading a book and you get ready to turn the page and you realize you have no earthly idea what was on the 2 pages you just read?
Yeah.
You're like, I know I'm turning the page, but I don't know what's coming next because I have no idea what I just read, right? So if you're really conscientious, what do?
You go back.
You go back and you're like, okay, this time I'm actually going to read. So some people define reading to be like my eyes passed over all the ink that's been printed on the paper. To me, that's not reading. To me, reading is reading for understanding. So yes, your eyes have looked over the ink on the paper, but you've allowed the ink and the writings on the paper to actually penetrate your brain a little bit, and your brain is now thinking about what was written. And I'll tell you what, with poetry, that's hard, isn't it? Certain poems, you read them and you're just like, what? Like that's my reaction too. I'm just like, wow. I get that those words were in English, but I have no idea what they actually mean, and it takes a lot of effort to try to understand what's going on. Usually it takes a teacher or someone that has learned before you to kind of help explain it a little bit. This is not quite poetry, but it does take some effort like that. It takes a lot of thought. So you're going to have to read. You're going to have to analyze, reading carefully. We usually underline certain things, underline some key ideas, highlight key ideas. And we're going to have to establish some variables. It's going to be x and y, typically. And then from that, we're going to have our system of equations. And then from there on out, it should feel pretty familiar. How do we solve systems of equations? Substitution, or? Elimination, or maybe even?
No, that's not it.
That's elimination still.
Yeah.
What's that third method that we learned? It was at the very start.
Substitution?
No, it's before that.
Oh, graphing.
Graphing, right? When you're graphing 2 lines, we're looking for a solution, and the solution is where what happens?
The lines intersect.
Lines intersect, yeah. So there's 3 methods we could use. Hopefully those are familiar methods to you. We're going to go ahead and try example number 1. Yeah, let's go ahead and take that first step. Will you guys take a minute and read it? I'll scroll up for you. Check it out. Do you guys remember from before when we did these sorts of problems? Didn't we have a problem kind of like this in our notes? Mm-hmm. Do you remember what it involved?
A garage door.
I thought, no? I thought somebody said it.
Yeah, it was like,
Oh,
we needed to
You had to do like a garage door.
Yeah, that was on a quiz.
I thought it was
we had to do, it was like a pipe that was
Or
cut
like
into
rope.
4 pieces.
It was a rope. Yeah, that's what I was going for. It was cut into pieces, right? Yeah. Do you guys remember the rope problem? This essentially is like that. Let's go ahead and read it together. I'll read it out loud. You guys read it with me here. It says a plumber needs to cut a 16-foot pipe into 2 pieces. The longer piece is to be 1 foot longer than the shorter piece. Find the length of each piece. So with all of these, I'm going to ask you guys the question, should we draw a picture? That's a good problem-solving strategy, potentially. Yes, picture? I'll go for that idea. So a picture of this pipe. There we go. There's the pipe. All right, so the full length of the pipe is how long? I agree, yeah, 16 feet. So what I'm going to do is I'm going to label it like that. So I'm going to say from here all the way to the other end is 16 feet. But some ideas here. What is the plumber going to do to the pipe?
Cut it.
He's going to cut it. So that's a key idea. So he's going to cut this pipe into how many pieces?
2.
So how many cuts is he actually going to make?
1.
One cut. And so let's, on our picture, on our diagram here, I'm going to go ahead and, put that in here, just represent it, the cut with something like that. I'm going to say he's going to cut it, say somewhere in there. Now, do we have any idea where he is going to cut it?
1 foot longer than 2 times.
Yeah, but that's kind of complicated. Let's think very simple. Do we know exactly where he's going to cut it? We really don't, right? We can't say, hey, he's going to be like 8 feet on each side. Maybe it's that, but based on what Ben just said, probably not, right? The 2 pieces, the result probably won't be equal length. So you can't say it's going to be 8 and 8 or like 10 and 6 or something like that. So in math, if we don't know how to express something numerically, what do we use?
Algebraically.
X, variables, X and maybe in this case, Y. So he's going to cut this into 2 pieces. Let's try to label our picture the same just so we can all have kind of the same process here. We're going to label one of these pieces X and the other piece Y. Based on the way that I drew my picture, which one looks like the longer piece?
Y.
So we'll maybe use that a little bit later. I would say, though, right now, remember, this is going to be a system of equations. How many equations do we need for a system?
2.
2 or more. I think we can actually write an equation right now based on our picture. What equation do you think we could write? What do you think, Christiana? You had your hand up first.
Well, there's one equation that we could write by the picture.
Let's just use the picture right now.
Okay.
What do you think we could write from the picture?
16 equals x plus y.
Yeah, very good. So x plus y equals 16. All she's really saying there is you take the short piece and the long piece and you add them up, you get the whole thing. Make sense? All right, so x plus y equals 16. But if this is a system, which it's going to be because we got these 2 variables here, we need to carefully write a second equation. Jake, you had your hand up really quick.
Yeah.
What is telling you? Looks like maybe you have a second equation. What do you think?
Y equals 2x plus 1.
Okay, what part of the question told you that is it? What were you looking at?
So x is the shorter piece.
Okay.
And so it's the long piece is 2 times, y is 2 times as long as the shorter piece.
So twice tells you 2 times, okay?
And it's also 1 foot longer too.
Okay, so the longer piece, which was y, right,
Yeah.
is 1 foot longer than twice the shorter piece. So what do you guys think of his interpretation? Obviously, he's got some key words going on there. Is his interpretation good, or do we need to tweak it a little bit? What's your opinion? You're getting thumbs up and good. Yeah, Jake, I think we can agree on that one. I think that's very well done.
Sweet.
So once we have these 2 set up, the objective, it says find the length of each piece. Check out our system. And I think it's really important for us to be wise about this because there's lots of ways to do it. I think there's one way that presents itself right away. What method, Ben, what do you think? What method is, why do you say substitution?
Because y is solved, it's solved for y in the bottom one, so we can just substitute 2x plus 1 in for y in the top one.
Let's do that. So give it a try. Let's see if you guys can use your substitution skills. Looks like maybe Hunter already did that. Yes? Nice work. Let's use your substitution skills, see if we can find the length of the short piece as well as the long piece. Okay? Give you guys a couple minutes to do that. Colby, can you explain how you work this one?
Yeah, so for the first equation I did x plus 2x plus 1 equals 16.
So if you had to explain what Colby just did there, what would you call that step? That's the substitution step, isn't it? He removed the y, he put 2x plus 1 in its place. Okay, so let's just get the quick details from you here, Colby.
So 3x equals 15 because you subtracted 1.
Yep.
And then divide by 3, so x equals 5. And then you plug 5 in for x on your equation.
Okay, which one did you use?
The top one.
Okay, so plug 5 in for x.
And subtract 5 both sides, and y equals 11.
So in the context of this question, what does that mean? What does the 5 mean?
5 feet.
5 feet and 11 feet. Yep, so 5 feet for the short piece and 11 feet for the long piece. And I think we're good. You guys get the same numbers as Colby there?
Yeah.
Okay. So how does this seem? Does it seem okay?
Yep.
Seem to go pretty smoothly for you? Any questions?
You need substitution, really, and how did you get from those two equations there to that one equation?
You have to be a little more specific than which equation are you talking about?
Those two equations, x plus y equals 16 and y equals 2x plus 1.
So those two.
Yeah, how do you get down to x plus 2x?
So I got to admit, Colby did this, but I do agree with Colby. So what I think Colby was thinking is, down here in this bottom equation, y and 2x plus 1 have the same value, right? And we know that because they're equal to each other. So what that means then is in the other equation up here, anytime I see a y,
You just plug that in.
I can replace it with 2x plus 1. So this arrow here is saying that we rewrote that top equation, and instead of a y, I substituted in 2x plus 1 for it. Does that make sense?
Yep.
From a substitution standpoint? Okay. Anybody else? Thank you for asking. Amelia, you doing okay?
Yep.
Okay. Everybody's happy? Okay, moving on then. Let's take a look at number 2. Take a second and read it, and let's think about that. Discuss amongst yourselves what you think. Obviously, you've identified a keyword, complementary, right? Think about what that means. Talk amongst yourselves. See if you can come to a conclusion. What does it all mean? The difference of the measures of two complementary angles is 64 degrees. Find the measure of each angle. So, guys, before you just jump in,
Quite a few things about it.
there's a lot of things we could say about this, right?
Like there's more than one answer.
Yeah, I actually disagree. I think there's two angles that this works for, and that's it. Well, we'll explain in a second. So, guys, picture? No picture.
No picture. I think the picture would be relatively simple.
Okay, I agree it'd be relatively simple, but let's go ahead and do it. Complementary being the key word there. Did you guys come up with what that means? Complementary means two angles that do what?
Add up to 90 degrees.
Add up to 90 degrees. Make a right angle. So I would say, draw a picture like this. There's my right angle. And I'll put just some other random angle in there. So do you see my two angles there? They add up to be 90 degrees.
Yeah.
What should I label my angles? Because I don't know what either of them is. X and Y. Okay, so let's make this one X. Let's make that one Y. You could use A and B, C and D, whatever you want. You could use Greek letters even if you wanted to. That'd actually be fairly appropriate to do. So based on the fact that these angles are complementary, we can actually write an equation right now. What X plus Y equals 90. Very good. X plus Y equals 90. The reason we can say that is we know that since they're complementary angles, they have to add up to be 90 degrees. And so looking at our picture, I think we can say that for sure. We got to come up with two equations, right? So we need one more. It's in the wording, right? What is the other equation? Ben, what do you think?
Y minus x equals 64.
So he said y minus x equals 64. Where did you come up with that one, Ben?
Because the difference of the two x and y, and the difference is subtraction, and they're
You said difference is subtraction?
Yeah.
That's right. So I gotta be honest though, does it make any difference, the ordering on the y minus x? I don't think it makes any difference. I think he could have written x minus y. Ben, is it okay if I do that?
yeah.
I think that's going to make what comes next a little easier. So if we write x minus y, it's exactly the same idea as what Ben came up with, just written a little different order. What system method presents itself now?
Elimination.
Elimination. Why do you say elimination, Alec?
Because there's like a negative x or negative y and positive y.
Yeah, it's got that pattern of opposites right there. So whether you did the y minus x or x minus y, you'll still have the pattern of opposites. So if you guys could, take a minute, see if you can solve this system on through and see what happens. And will you talk us through how this one's going for you?
Oh, yeah.
think I did this right.
We got our system set up. What would you do first?
Oh wait, that doesn't.
So the y's cancel out.
So we're going to add. Okay, so when we add, you said the y's cancel out. What do we get when we do that?
X equals 154.
Close. I agree with the 154, but I don't agree with the x. I agree with
So what would just
Dos Equis.
x is 76? Because I don't want to do math.
Same, does that make sense? X plus x is 2x.
And then you divide both sides.
And then you divide both sides by 2. There we go. So when you divide 154 by 2, do you know what that is?
77.
77, yep. Okay, so one angle is 77. I got to find the other angle. If x is 77, y has to be what? 13, right? Just subtract 77 from 13. So there's your angle measurements. So maybe you put 77 degrees or 13 degrees there would be appropriate. I don't think that'd be anything I'd take off for, but it would be appropriate. Yeah, go ahead, Danny.
I got something different.
Okay, what did you get?
I got x equals 28 and y equals 62.
Okay, so let's go back then and let's check out what happened, why we disagree. So if we go back to this point right here, do you agree with the system that we have?
Yeah.
X plus y equals 90, x minus y equals 64. So then let's hear your steps, how you got to the answers you said.
So I did elimination.
Okay.
So then I ended up getting 2y equals 124.
Okay, so 2y. So we must have a slightly different setup then.
Yeah, I did y plus x instead of, so I just flipped them around.
So you did x plus y equals 90. So you totally agree with that one?
So no, y plus x equals 90, then y minus x equals 64.
Okay, let's do that. So you said y plus x equals 90, y minus x equals 64?
Mm-hmm.
So we totally agree now?
Yeah.
Okay, so when you did your elimination, tell me again what you got?
2y equals 124.
Should be 154.
Oh, I added wrong.
That's all it is.
Yeah, okay, I see it.
And then I think when you divide by 2, you'll get that same 77 we got before. And then x equals 13 based on that. Is that good?
Yeah.
Thanks for asking. Anybody else with a question? Go
Can
ahead.
I argue my point?
Very quickly.
So, it says,
Let's try and pick out keywords. Let's identify if a picture is helpful or not. So this one says, a pet owner wants to make a rectangular dog run from 28 feet of fencing. If the length of the dog run is to be 10 feet longer than the width, find the length and width of the area that is enclosed for the pet. So first off, you've had a chance to kind of hear it, kind of read it a little bit. Do you think a picture is worthwhile here? Yes or no?
Yes.
I heard a yes, saw a couple of nods. I'm sorry you're outnumbered, Hunter. So if I was going to draw a picture here, isn't it really just a rectangle? So it should be helpful. It's not going to be a super detailed picture. So here is my rectangle for the dog. And since you all wanted a rectangular dog, there you go. Rectangular dog in the rectangular dog run. Okay, so what are some things we could label on our picture that might be helpful as we try to turn this into math? Christiana?
Well, you could do the width as W,
Okay,
and the length as W plus 10.
let's not go there yet. We're going to do a system, so let's have two different variables.
Okay.
I like that idea. That would have
Why?
been what we did before. Well, how about you said length, so can we just use L?
Well then, yeah, but doesn't that take away a step then?
I don't know. I was just going to go with this, W and L.
Yeah, but what is that labeling? I don't get
It's labeling the sides of the rectangle.
that. Yeah.
It's saying this side is W, this side is L. Just so we have something to work with instead of saying, hey, that one side and that other side. You know, we can say X and Y, W and L, A and B, whatever. We just want to have something to work with as opposed to just blanks, right?
Okay.
What do you think, Ben?
I have an idea for the circle.
Okay, hang on just a second. We haven't written any equations yet. All we've done is we...
That was the equation.
Yeah, I have the equation, I think.
For the first equation.
Okay, let's hang on just a second. What do you guys know to be true about a rectangle?
The sides add up.
What about opposite sides?
Oh, they're the
They're
same.
identical.
They're the same, right? They're equal. So wouldn't this also be a W and this would be an L? Okay, so maybe from the picture and maybe a little bit from the wording, anybody think they have an equation? Anybody think? Go ahead, Christiane, let's hear.
Okay, so I think it's 28 equals 4W plus 20.
Ooh, okay, let's think this one through. Where did you come up with that?
Okay. Well, if you like read so the 28 length of fence is what they're making
Right.
out of, so that's the total.
Right?
And then you do, if the length of the dog run is 10 feet longer than the width, so you do the width plus 10, so W plus 10,
Okay.
twice, and then the width is W, so
Okay.
4W plus 20.
So I think we're going to find out if you're right here in a second. What I think you're doing actually is you are like substituting in the midst of your setup.
Yeah.
So let's not do that and let's see if we come up with the same thing.
Okay, well, can I solve mine and then we'll see if
Hold on. Yeah, hold on. Let's make sure your setup is good, right? So if your setup is good, then I think we're good. But Christiana,
Yeah.
I want to mention something. It says use systems of equations. And so I got to be honest, if I was looking at this question on a quiz, I want to see evidence that you used a system. And I would say that's not evidence that you used a system. Okay? So let's see if it turns out to be the same. Let's see if your thinking was good. But let's see systems too.
Okay.
So Ben, you had an idea about maybe a slightly different setup?
2W plus 2L equals 28.
That was kind of what I was going for, and that's expressing perimeter, isn't it? And you said that, right?
Yeah. I was thinking of like substitution and not.
Right. Distribution?
No,
No.
I don't. Isn't he gonna do another equation and then he's gonna add them?
I don't know what he's going to do for a method, but I would say that as far as the system goes, we've got this one equation has two variables.
Oh,
I'd be
okay,
looking
so
for
a
that.
system has two variables.
Two different variables.
Okay, I just didn't know what a system was.
It's like what we said at the start, two equations, two variables. Okay. Okay, so Hunter, yeah.
Can you just do L plus W equals 28 because that's the area?
Ooh, okay, let's talk about that. A couple things going on. You said L plus W. If you said L times W equals 28, that would be a valid thing. That would get you into some pretty scary territory, though, from a substitution standpoint, because you'd have denominators. I don't know if it would be the best. And the other thing about that is, Hunter, 28's not the area,
Oh, yeah.
right? Because it says 28 feet of fencing. That means that's more of a perimeter idea. And so we really have to stick with perimeter for the 28 number. Okay, so I would say this equation number one from a systems standpoint makes sense. We got to come up with a second equation, and it's in there. Jake, what do you think?
Could it possibly be, this might be wrong, L equals W plus 10?
L equals W plus 10.
Yeah. I think that's.
So did you get that from here? The length is to be 10 feet longer than the width.
Yeah.
L equals W plus 10. Does that go with that wording?
Yeah.
You sure?
Sweet to know. I think so.
No,
The length,
that doesn't match what our little things are. Does it?
Or what do you mean our things are?
Wait, does that match with our variables or whatever they're called? The W
In our
and the L?
picture, the width is longer than that.
Yeah.
Oh yeah, the picture's not necessarily to scale, I guess, right?
Well, never mind.
I see what you're saying. Like in my picture, the W is longer than the L, right?
Yeah.
But according to the wording would be what we'd want to go with, right?
Yeah.
I agree with you that my picture, maybe what I should do to make this make a little more sense is do a little switcheroo here. Make this the length and this the width. Because that was kind of arbitrary how I did that, wasn't it?
Yeah.
And so does that make a little more sense with the picture? Okay. So I would say based on the wording, I agree with you, Jake. Definitely agree. You had a lot of folks saying, yep, I think he's right. And I agree with you. I think we're going to find that maybe Christiana's
Mine did work.
substitution probably was a good substitution, but you did it in your head. And so I would want to, like from a quizzing standpoint, I would want to see two separate equations, then maybe a substitution step, evidence that you used the system, and then the answer. So just be careful with that. So you guys see how it's set up for substitution pretty nicely? If you haven't already done so, please run with it all the way to the end. See if you guys can find the length and the width. Ready? Go. All right. So from a substitution standpoint, hey guys, hey, here's what we would do. Anytime I see an L in equation number 1, I can replace it with W plus 10. So I would write something like this. 2W plus 2L technically, but in place of the L, I'm going to put W plus 10. Here's where I think we see Christiana's original idea coming through. What property do I have to use here? Distributive. Yep, the 2 gets distributed across. So it's going to be 2W plus 2W plus 20 is equal to 28. So I come up over here. I get 4W plus 20 is equal to 28. And again, I want to emphasize to you, the only difference between what Christiana said and what we did is we showed evidence of a system with substitution. She didn't. We want to see that evidence, especially if it says use a system to do that. If it doesn't say, Christiana, I just want to be clear about this. If it doesn't say use a system, then your way works great because you kind of did the substitution in your head. Okay, so you subtract 20, you get 4W is equal to 8. So the width is equal to, wow, doesn't it seem kind of skinny to you? A 2-foot wide dog run? Doesn't have much room to roam. Yeah, hopefully it's a small dog. So if W is 2, what is L? 12, right? You can just use this. L equals W plus 10. 2 plus 10 is 12. So 2 feet and 12 feet. Poor dog. Okay. Can't even turn around. Yep, it's pretty much stuck. I think you'd be amazed, actually. I'm going to skip. I'm going to go to number 6. Let's skip 4 and 5. We'll come back around to 4 or 5. Maybe today. Maybe on Thursday. I want to skip ahead to number 6. I just want a little variety here. Take a look at number 6. This one's a little different. Let's carefully read. Let's decide whether we want a picture or not. Maybe we do. Maybe we don't. And decide what's going on here. It says a boat traveled 20 miles downstream in 2 hours and made the return trip in 5 hours. Find the speed of the boat in still water and the speed of the current. So let's decide on this right now. Picture or no picture? Picture? No picture? Amelia, any opinions?
No.
You vote no picture. Okay, I can live with that. So this boat is traveling downstream, then upstream. Let's get like a broad perspective on this. Like what kind of relationship, formula, setup is happening here? What do we got? Come on. There's a D equals RT. That's right. That's right, Alec. D equals RT. We got a boat with a distance, a rate, and a time. The relationship is D equals RT. And so that's what we're going to go with. So, guys, like we've done before, we're going to use a little graphic organizer to help us get going with this. So I'm going to do that here. I'm going to draw a couple of columns, a couple of rows, like this. I'm going to have a rate column. I'm going to have a time column.
Wait, do we still have to use systems?
Yep, you absolutely have
Oh
to.
my god.
You have to use systems here. You okay?
Yeah.
What's wrong?
No, I don't, never mind.
Okay. Yeah, you really have to use systems here. I don't think there's any way around that. All right, so there's some stuff that I think is really easy to fill in. You know, for instance, we've got the boat is going downstream. You guys, what does downstream even mean? With the water, right? With the current. Okay. And then upstream means against the current.
We just do D in here.
D, well, careful, we're not doing any variables yet. I'm just saying the first row is the information for downstream. We'll talk about the variables in a second. The second row is for upstream. But before we get to any variables like Ben is talking about, aren't there some numbers that we can just plug in immediately? Like, what do you see?
Well, for one of the equations, you can put the distance as 20 miles.
Okay, so
You can do it for both.
how about both? Because it doesn't say it makes the return trip. Doesn't return trip mean it's the same trip as before?
Yeah.
So I'd say the distance for both downstream and upstream is 20.
And then
What else do we know? The time. What are the times? So time downstream, Evan, is what? 2 hours. And upstream? 5 hours. Here's where we get into the idea of what downstream and upstream really mean. Right? They have a very specific meaning. So if you've ever been in a canoe or any kind of a boat that was human powered, you very much know what upstream and downstream mean, don't you? Right? So if you are going upstream, don't you have to paddle really hard to even move? It's very hard to even move. But if you're going
Very hard to even move backwards slowly.
yeah, it is. Yeah, right. You're fighting that current. That current is so powerful, right? It's very difficult to even to like hold yourself back, right? Even hold still would be difficult. So when we think about the rates, can we use B and W for the rate of the boat and the rate of the water? Rate of the boat and rate of the water. So if you're going downstream, isn't the water helping the boat go faster? So what do you think we could write for rate downstream?
The water? For the
B plus W. That's right. The rate would be the rate of the boat plus the rate of the water. That's going to give you your overall rate because the boat and the water are working together to go really, really fast. What do you think about the rate upstream?
B minus W.
B minus W. Yep, boat minus water would be your rate going back upstream. So hopefully, I'm assuming this is some kind of a motorboat or you got a lot of people rowing, because if it's just one person, I don't think it's going to work. So the final thing we want to do is get the relationship here. We know that distance is equal to what?
equals MC squared.
Well, it's equal to 20, but isn't it rate times time?
Oh, that's what you.
Yeah, so here is your system of equations. It's right here. B plus W, parentheses, times 2 equals 20. And then parentheses B minus W times 5 is equal to 20. You just multiply rate times time to get your distance. If you guys would, take a minute. I think probably a distributive property would be wise here. Do a distributive property, and let's get our system going. What do you think, elimination or substitution?
Elimination.
Definitely elimination, because it'd be pretty easy to get the pattern of opposites set with these. So, take a minute, please try it. Amelia, did you do any multiplying on the equations?
I don't really know. I got lost. So.
Where are you lost?
I was able to distribute all of that and then.
So did you get to the same spot as me?
Got to there, yeah.
Okay. So let's talk that through then. Hopefully this will help you out. So did you notice that the W's, one of them is positive, the other one's negative?
Yeah.
That's a good start to getting that pattern of opposites, but obviously one of them is 2, the other one's 5. We need them to be the same number, but just opposite signed. So what I would do is I would look at that top equation, the 2, and the bottom equation, the negative 5, and think, all right, what do I need to multiply by to get those to be the same number, just opposite? 10, right. So what would I multiply the top equation by?
5.
Yep, so if I multiply this one by 5 and the bottom one by 2, I should have it. So that would give me 10b plus 10w equals 100. And that would also give me 10b minus 10w equals 40. That make sense? Okay. So once you have that established, now you can just add to eliminate. So it would be 20b is equal to 140. This is a ridiculously fast boat, isn't it? I'm being somewhat facetious.
No, it's going 7.
7. It's not that fast, is it? The boat's speed in still water is 7. So if the boat's speed is 7, if you plug back in, anybody getting a W yet? 3. So B equals 7 for the boat, W equals 3 for the water.
These seem much easier than they were before.
Plug back in. So to any of the equations. B equals 7, yeah, to any of them. So I would say, yeah, maybe this one. Whoa. Hey, Rocky. Maybe this one that I just put the box around.
Yeah, that's,
7 plus W. You could even use the one where you already distributed. Rocky, honestly, you've got 4 equations to pick from. Just plug back into any of them. 7 and 3, Sam. Yeah, that's right. That's right. Good job. Very good. Okay, Rocky, I'll show you. Rocky, what I think I would do, you get the B equals 7. I would plug back in maybe right here. So I'm going to take 7 and plug it in for B. 2 times 7, yeah, 14, plus 2W equals 20. So like you said, 14 plus 2W equals 20. Subtract 14, you get 2W equals 6. Dividing by 2, you get W equals 3. But my point, though, earlier, Rocky, is that you could use any of the 4 equations to accomplish that. You just got to figure out what's going to be easiest for you. Any of them will work. Anybody else?
Wait, don't we have to go back to like the speed of the boat?
Yeah, so the speed of the boat, we set it up to be W. So I'd say, or sorry, B, and speed of the water was W. So speed of the boat is 7.
Wait, then why do we have B plus W and then B minus W?
So that's the overall rate when the boat's in the water. So if a boat has the capability of going 7, that's one thing. But if it's in water flowing at 3 miles per hour, and it's going with the water, the speed is not 7, it's now 7 plus 3.
Okay.
So we were looking for the speed of the boat and the speed of the water.
Alright, got it.
Okay. Anybody else? Any other questions? Go ahead, Amelia. Oh, goodness. I don't know. I'd have to think that through. More than one, right?
yeah.
Less than 100.
Probably less than 100 as well. Yep, I agree. Any other questions?